Hello viewers, in today's class we are going to discuss one important conceptual problem from integrals involving modulus function, right? And in this lecture we'll see how to evaluate this integral that is from pi by 2 to pi, and here we have mod of sine x minus cos x, right? So in our previous two videos or two lectures, we have evaluated these two integrals, right? So in the first lecture we have seen 0 to pi by 4 mod of sine x minus cos x. Then from pi by 4 to pi by 2 we have seen mod of sine x minus cos x, and in both the cases we have seen that the value of this integral is root 2 minus 1, and this is also root 2 minus 1, right? So now in this lecture we'll see the value of this integral from pi by 2 to pi, right? So this point is pi by 2 and this point is pi, right? And here we are using the same graph which was used for calculating these two integrals, right? So here the blue curve denotes or it represents the cosine function, and the red curve shows the sine function. So now let us call this integral as I, right? And from the graph we can see that sine function and cosine function, they intersect at pi by 4, right? So if we take the quantity which is inside the mod function equal to 0, that is if we take sine x minus cos x is equal to 0, then we have sine x is equal to cos x, and then for x is equal to pi by 4, sin x and cos x are equal to each other, right? So this is the point of intersection of sine function and cosine function for x is equal to pi by 4, right? But here our limit of integration are from pi by 2 to pi, so we are concerned with only these limits, that is from pi by 2 to pi. So now let us take the interval that is from pi by 2, from pi by 2 to pi, right? So here we have x lying between pi by 2 and pi. Now let us look at the graph. Now see, when we go from pi by 2 to pi, we can see that the red curve, it always lies above the blue curve, right? So the blue curve is for cosine x, the red curve is for sine x, right? So the red curve, it always lies above the blue curve, right? So it indicates that, or it implies that sine x is always greater than cosine function whenever x belongs to this interval pi by 2 to pi, right? So sine x minus cos x is greater than 0 for this interval that is from pi by 2 to pi. Now, for example, let us take some point here between pi by 2 and pi, right? So let us take the point, say x is equal to 120 degrees, and 120 degrees is 2 pi over 3, right? And this belongs to the interval pi by 2 to pi. Now see, the value of sine 2 pi by 3 is positive, right? Because in the second quadrant sine function is positive, right? And the value of cos 2 pi by 3 is negative, because in the second quadrant cosine function is negative, right? So now let us see this quantity which is inside the mod function, that is sine x minus cos x, right? Now see, sine x is positive, right? And cosine x is negative. Now this negative and this negative when multiplied together, they become positive. So we have positive plus positive, that is equal to positive, right? So sine x minus cosine x is always greater than 0 for all values of x which lies in this interval, right? So now let us define the mod function. Mod of p is defined as positive p whenever p is greater than or equal to 0, and negative p whenever p is less than 0, right? Now see, if we take p as sine x minus cos x, then we can see that this p is greater than 0, right? So mod of p should be equal to positive p, because p is greater than 0 as per this definition, right? So we can now write mod of sine x minus cos x should be equal to positive sine x minus cos x, right? So now this integral I can be written as pi by 2 to pi, and here we have positive sine x minus cos x, and here we have dx, right? So now the integral of sine x is minus cos x. The integral of cosine x is sine x, which is minus sine x. And here the limits are from pi by 2 to pi, right? So now before substituting the limits, let us take this negative sign outside. We have cos x plus sine x. Limits are from pi by 2 to pi. Let us substitute the limits. We have cos pi plus sine pi. Then we have minus, we have cos pi by 2 plus sine pi by 2, right? So we know that cos pi is minus 1, sine pi is 0, and cos pi by 2 is 0, sine pi by 2 is 1, right? So we have minus, and here we have minus 1, and here we have minus 1. So this is minus minus 2, that is equal to positive 2, right? So the value of this integral is equal to 2. So viewers, this is how, by making use of the graphical representation of sine x and cosine x, we can find out the value of this integral, which is equal to 2, right? So now viewers, here is an important question, right? Suppose we have to find the integral from 0 to pi, and we have mod of sine x minus cos x, right? So in this case, what we will do, we'll split the limits from 0 to pi by 4. Then we have pi by 4 to pi by 2, and then we have pi by 2 to pi, right? And here we have dx, dx, and dx, and here we have mod of sine x minus cos x. Here also we have mod of sine x minus cos x. Here also we have mod of sine x minus cos x. So now we have obtained the value of this integral as root 2 minus 1 from 0 to pi by 4, right? So we have root 2 minus 1, and the value of the integral from pi by 4 to pi by 2 is again root 2 minus 1. And in this lecture we have seen that the value of pi by 2 to pi, mod of sine x minus cos x, is equal to 2, right? So now if we add these three numbers together, then we have 2 root 2 and minus 2 plus 2, that is equal to 2 root 2, right? So here we have made an important conclusion that the value of this integral, that is 0 to pi mod of sine x minus cos x, is equal to 2 root 2, right?